So what we're going to talk about today is solving polynomial equations by factoring and using the zero product property. And this gray box at the top of the page explains the process that we need to go through in order to do this. When we have a polynomial equation, which you can see on the rest of this page are several polynomial equations, the first thing that you want to do is write your equation in this form. So essentially what you want to do is add or subtract so that you get the whole polynomial on one side of the equation and the other side has 0. Okay? And ideally you're going to choose the side so that your x squared term is positive. It'll make life a lot easier. After you do that, your second step is to take this polynomial and use your factoring skills to factor it. Then you're going to use the zero product property to solve it. And remember, the zero product property says that if we have two things multiplied and together their answer is 0, that one of those two things has to be 0. So this is the zero product property. All right, so our very first problem here. I already have everything on one side, so I don't need to use adding and subtracting to move anything. And so now I'm going to factor. This is an easy one because I don't have anything in front of x squared. So what multiplies to 6 and adds to 7? That's 6 and 1. So here we have x plus 6, x plus 1. And this equals 0. So if these two things multiplied equals 0, then either x plus 6 is 0 or x plus 1 is 0. So that's going to give me two equations to solve. If I subtract 6 from both sides of this equation, I get x equals negative 6. If I subtract 1 from both sides of this equation, I get x equals negative 1. And remember, we already learned that the degree of the polynomial, which in this case is 2, tells us through the fundamental theorem of algebra that we're going to have two solutions. So we know we're going to have two solutions. All right, let's go to B. And again, everything is already on one side and we have 0 on the other. So we're going to factor this. Remember, the very first thing you always want to check for is a greatest common factor. And the greatest common factor here is x. So factor out an x, and we're left with 2x minus 3 in parentheses. So now I have two things multiplied equals 0. So either the x is 0 or 2x minus 3 is 0. And I'm going to write two equations. So x equals 0 is one solution. Here, if I add 3 to both sides, I get 2x equals 3. And if I divide both sides by 2, I get x equals 3 over 2. So there are my two solutions. Let's go to the next example. Now, first of all, I don't have 0 on one side. So I want to move everything to the side where the x squared term is positive. So I'm going to move everything to the left. So subtract 18 on both sides. And I have x squared plus 7x minus 18 equals 0. And now I need to factor this. There is no greatest common factor, and this starts with x squared. So all I need is what multiplies to negative 18 and adds to 7. That's 9 and negative 2. So x plus 9, x minus 2. So now these two things multiplied equals 0. So either that x plus 9 is 0 or x minus 2 is 0. Subtract 9 from both sides and we get x equals negative 9. Add 2 to both sides and we get x equals 2. And remember, you can check your answers one at a time by plugging them back into the original equation here and seeing if they work. Now, in this particular example, example D, notice, I want to move everything to the side where the x squared term is positive. The x squared term is positive on the left, so I'm not going to subtract x squared from both sides. I'm going to subtract x and subtract 30 from both sides. So I have x squared minus x minus 30 equals 0. I have no greatest common factor. I have nothing in front of my x squared, so what multiplies to negative 30 and adds to negative 1? How about negative 6 and positive 5? So x minus 6, x plus 5. These two things multiplied equals 0, so either x minus 6 has to be 0 or x plus 5 has to be 0. If I add 6 to both sides, I get x equals 6. If I subtract 5 from both sides, I get x equals negative 5. All right, on to example E. Example E. I need everything on one side. So I'm going to subtract 10x from both sides. But when I do this, on the left-hand side, I want to put everything in descending order so it's easy to factor in the next step. So I don't want to put x squared plus 25 minus 10x. That's not easy to factor that way. I'm going to write it as x squared minus 10x plus 25 equals 0. All right? And now I'm going to factor this. So no greatest common factor, nothing in front of x squared. So what multiplies to 25 and adds to negative 10? That's negative 5 and negative 5. Or you can write it like this, x minus 5 squared. Either way. So now I know that x minus 5 has to be equal to 0. And I'm going to add 5 to both sides, and I get x equals 5. Now, the interesting thing with this is this factor occurred twice. All right? So this solution actually occurred twice. And so it's what we call a double root. It occurred twice in the same problem. All right, let's go to F. So with F, first thing we want to do is move everything to the side where the x squared term is positive. So subtract 10x on both sides. Subtract 8 on both sides. And I get 3x squared minus 10x minus 8 equals 0. I need to factor this, but I have no greatest common factor. And I do have a number in front of x squared. So here's what I'm going to do with this one. I'm going to try the box method. So I'm going to draw my box out here on the side. This is a great opportunity to refresh your memory how to do this. The 3 goes in the first box, the negative 8 in the last box. We multiply them and get negative 24. So I need two numbers that multiply to negative 24 and add to negative 10, and that is negative 12 and positive 2. So I'm going to put those numbers in the remaining boxes. Now my greatest common factor in my first column is 1. 1 times 3 is 3. 1 times 2 is 2. And 3 times negative 4 is negative 12. So my factors are x minus 4 and 3x plus 2. This is 1x minus 4 and 3x plus 2. If these two factors multiplied equals 0, then either x minus 4 equals 0 or 3x plus 2 equals 0. Add 4 to both sides and I get x equals 4. That's one solution. Subtract 2 from both sides and I get 3x equals negative 2. Divide both sides by 3 and I get x equals negative 2/3. All right, let's go ahead and turn the page. I've got some more examples here, but some of these are a little bit more challenging. A is a little bit challenging because I have found that students look at this and think to themselves, let me divide both sides by x squared, all right? And we don't want to do this. You never want to divide by x when you're solving these. Remember our steps, which are here at the top of the page. Rewrite the equation so one side of the equation is 0. So in other words, what we want to do is subtract 36x squared on both sides. And the reason why we want to do that is because x to the 4th is our highest power. So we want to move everything to the side where this is positive. And so I've got x to the 4th minus 36x squared equals 0. And now I want to go ahead and factor. Now remember, my highest power is x to the 4th, and my fundamental theorem of algebra tells me that means I'm going to have 4 answers to this equation. Okay? So first of all, factor out my greatest common factor, which is x squared. And what I have left is x squared minus 36. Now, the way that I can deal with this is the difference of two squares, x squared and 6 squared. So this factors bring down my x squared to x plus 6, x minus 6. All right? So here's what I've got. I've got 3 things multiplied equals 0. Therefore, one of these 3 things is 0. So either x squared is 0, x plus 6 is 0, or x minus 6 is 0. Now here, I could square root both sides, and this would give me x equals 0. Now, keep in mind, this happened twice because it's x squared. So this is a double root. So there's 2 of my answers. Here, subtract 6 from both sides and we get x equals negative 6. Here, add 6 to both sides and we get x equals positive 6. So my 4 answers are here, 6, negative 6, 0, and 0. Now, with example B, notice how this is already factored. It doesn't matter. You don't have 0 on one side, so it is not helpful. So believe it or not, here's what you have to do with this. You've got to FOIL it and get everything on one side. If you had a 0 here, you could say this is 0 or this is 0. But you don't, you have 40. So here's what you have to do. You're going to subtract 40 from both sides. So you can get 0 on one side. But what this means is you have to FOIL this. So when I FOIL this, and this is conjugates, so I know I'm going to have my inners and outers cancel, I get x squared minus 9, and then I have minus 40 equals 0. Combine my like terms, and I get x squared minus 49 equals 0. All right, now I need to factor. This is the difference of 2 squares, x squared and 7 squared. So this is x plus 7, x minus 7 equals 0. 2 things multiplied equals 0, so either that x plus 7 equals 0 or the x minus 7 equals 0. Subtract 7 from both sides and we get x is negative 7. Add 7 to both sides and we get x equals positive 7. And there's our 2 solutions. This is the same thing that we will have happen with example C. It doesn't matter that this is factored because you don't have 0 on the other side. So here's what you've got to do. You've got to subtract the x from both sides. And the only way to combine all this is to FOIL. So when I FOIL this, I have x squared My inners and outers are minus 6x and minus 6x, so that gives me minus 12x plus 36, and then I have a minus x equals 0. Combine my like terms. So I have x squared minus 13x plus 36 equals 0. Now that I have 0 on one side, I can factor this. So no greatest common factor, no number in front of x squared. What multiplies to 36 and adds to negative 13? Negative 9 and negative 4. So I have x minus 9, x minus 4. Two things multiplied equals 0. So either x minus 9 equals 0 or x minus 4 equals 0. Add 9 to both sides and I get x equals 9. Add 4 to both sides and I get x equals 4. Let's go to D. And we have the same situation with D. It doesn't matter that this is factored because we don't have 0 on one side. We need to get 0, so we're going to subtract 6x on both sides. And the only way we can combine all of this stuff is to distribute. So I've got x squared times x is x to the third, minus, x squared times 1 is x squared, minus 6x equals 0. All right, everything is in descending order. Factor out my greatest common factor, which is x. And I have x squared minus x minus 6 equals 0. Notice my highest power is the third, x to the third. This is going to have 3 solutions by the fundamental theorem of algebra. So now, I have nothing in front of x squared here, so what multiplies to negative 6 and adds to negative 1? How about negative 3 and positive 2? So x minus 3, x plus 2 equals 0. So I have 3 things multiplied equals 0. So either x equals 0, x minus 3 equals 0, or x plus 2 equals 0. So x equals 0 is one solution. Add 3 to both sides and we get x equals 3. Subtract 2 from both sides and we get x equals negative 2. So there's our 3 solutions. All right, let's go to the next page. With this particular example, again, we do not have 0 on one side. I'm not even exactly sure where I'm going to move stuff at this point. So what I'm going to do, I know I can't have this factored because I don't have 0. So I'm going to distribute this. So I've got 3x to the third equals 8x squared minus 4x. Now I can see everything's going to go to the left. So subtract 8x squared on both sides. Add 4x on both sides. And here's what I've got. I've got 3x to the third minus 8x squared plus 4x equals 0. I have a greatest common factor of x, so I'm going to factor that out, and it leaves me with 3x squared minus 8x plus 4 equals 0. Now this time, this doesn't look that hard. Let's see if we can do guess and check here. So I have the x. The only way I can get 3x squared here is an x and a 3x. The numbers I need to write in next have to multiply to 4, but my inners and my outers have to add to negative 8. All right? So they're both going to have to be negative to multiply to a positive and add to a negative. And I can see that this is going to be 2 and 2. My inners are negative 6x. My outers are negative 2x. That gives me negative 8x. So I have 3 things multiplied equal to 0. So either x equals 0 x minus 2 equals 0, or 3x minus 2 equals 0. So x equals 0 is one solution. Add 2 to both sides here and I get x equals 2. Add 2 to both sides here and I get 3x equals 2. Divide both sides by 3 and I get x equals 2/3. All right. The next thing that we're going to talk about is some vocabulary. These three statements all mean the same thing. Solve the equation. All right? And here's an equation to solve. All right? We know that we need to factor this and set our factors equal to 0 using the zero product property. Here's the other thing. This means the same thing. Find the roots of the equation. And it has the same equation. That means the same thing as solving it. So you're going to factor it and set each factor equal to 0 to solve. Here's the last thing. Find the zeros of the function, and it'll say f of x. And notice what's the same. This is right here. It's just that we have f of x equals that. If the directions say find the zeros of this function, here's what this means. It means you're going to take this right here and you're going to set it equal to 0 and solve. That's what find the zeros of the function means. So it's doing something you already know how to do, you just didn't know what it meant. All right? So here's an example. It says find the zeros of the function. F of x equals 3x squared minus 10x minus 8. All this means is that we're going to take this right here, set it equal to 0. So here's what I have. 3x squared minus 10x minus 8 equals 0. Now I go about solving this the same way I already know how to do, and that is this. Go ahead and factor. Use guess and check or the box method. Set each factor equal to 0 and solve each of those factors so that I get these two solutions. All right, let's go ahead and do an example. At the top of the page, I have f of x equals x squared minus 4x minus 12, and it says find the zeros of the function. So here's what I'm going to do. Set x squared minus 4x minus 12 equal to 0, and I'm going to solve it. All right? So, no greatest common factor, no number in front of x squared. So what multiplies to negative 12 and adds to negative 4? How about negative 6 and positive 2? So x minus 6, x plus 2. These two things multiplied equals 0, so either x minus 6 is 0 or x plus 2 is 0. Add 6 to both sides and we get x equals 6. Subtract 2 from both sides and we get x equals negative 2. These two numbers are the zeros of the function. And here's the thing. If I were to graph this function, what this means is this is where on the x-axis the graph crosses the x-axis. So if I go to graph this, you will see that it crosses the x-axis at 6 on the x-axis and at negative 2 on the x-axis. All right, I've got one last example, and it is a whopper. But it's always good to go through a nice challenging example. It says find the zeros of the function. Now, this is not factored because it's not things multiplied, it's things subtracted. So guess what I have to do to this? Foil this all out. Now, If I FOIL this all out, let me use binomial expansion to do this. And remember that we already learned binomial expansion. And remember that our coefficients for this would be 1, 3, 3, 1. So 0 equals x to the third. And then I have x squared and a negative 4. And a 3. And a 3 and an x and a negative 4 squared. And then finally a negative 4 to the third power. And then distribute my negative 4 here, and I have minus 12x plus 64. So I just need to simplify all of this. So I have 0 equals x to the third. Multiply the negative 4 and the 3, so minus 12x squared. Here, negative 4 squared is 16 times 3 is 48, so plus 48x. Negative 4 raised to the third power is minus 64, then minus 12x plus 64. And notice, the minus 64 and the plus 64 cancel. So I just need to combine these like terms. So 0 equals x to the third minus 12x squared plus 48 and minus 12 is plus 36x. And now I can factor. Factor out my greatest common factor of x, and it leaves me with x squared minus 12x plus 36. Nothing in front of the x squared, so what multiplies to 36 and adds to negative 12? That's negative 6 and negative 6. So 0 equals x times x minus 6 twice. So 2 things multiplied equals 0. So either x is 0 or x minus 6 is 0. All right? X is 0 is one solution. Add 6 to both sides and we get x equals positive 6. And this is what we call a double, not a root this time, but a double 0. Because we're talking about zeros of a function.